Hello, dear LoRaWAN community. If you are listening, the news today were much bigger disasters in the world as the one I'm talking about here. But for Germany, for our country, this event 2 years ago was really a catastrophe. We had this heavy rain and this terrible flood in the area called Ahrtal, which is a fairly small area, but nevertheless, we had a situation that 134 people died. And I know from the industry that the losses and the damages in the industry were about 600 million. And if you add all the damages in the infrastructure, destroyed streets, bridges, communication lines, gas pipelines, and so on, if you count all that together, you wind up with approximately 7 billion euro in damage. And even now, 2 years later, we are still working on recovering in this area and repairing. So there was an initiative in this area that the people said, some people came together and said, we must do something. We don't want to make that or to live that situation again. I mean, you cannot prevent the rain, of course, but the goal was that the alarming comes early enough to react. The death of the people were definitely something which could be prevented with the right measures. And that was the motivation that, leading by the Chamber of Commerce in this area, and some local people and the University of Wuppertal and so on, they all came together and said, well, let's do something. We don't want to wait for any big solution. We want to do something. We want to get started. And one of the motivation was two things. I mean, there are already some sort of water level measurement devices somewhere. But the problem is you need this information in due time. If you talk about real time, we are not talking here about milliseconds, but we are talking about maybe minutes. We should have that information in real time, and we should know what's going on. We need some sort of prediction what's going to happen. What is the situation in 3 hours, in 4 hours, in 5 hours? So that was the idea. Sorry, I'm too far. Don't know how to go back. Oh, anyway, this foil before showed the partners who came together to realize this project. And here I show you 3 situations how flood spreads out over the river if certain rain occurrences take place. And if you look at the very right one, it is a situation where the meaning was before that happens maybe one time in 100 years. But we see that more often now than it was supposed to be in the past. So we cannot be sure that it takes another 100 years to have an occurrence like that again. So what were the requirements? The requirements, this area, if you look at this area has a lot of hills and valleys. It's an area like that. It's not at all flat. And because they know since long times that water can build up and create some danger, they have a lot of reservoirs in the woods and in the landscape where water can be stored. But the situation is nobody knows what is the situation on this location. There are sometimes people walking by and looking, but maybe once a week or once a month, but not even close to any real-time situation. And of course, to install something in these areas, I mean, there's no infrastructure. You have no Ethernet connection, you have no power, you have nothing. So it was very clear what we need devices which are autonomously, which work independent from any infrastructure. And it's clear we want to collect data 24/7 every day. And since the amount of sensors which are spread over the area, because we want to get a real complete picture about the whole scenario. Yeah, there is a lot of data coming in, and it is not a solution to have a dashboard and showing these data on a dashboard, and people are looking at that dashboard, and at 5 o'clock they have finished and go home. That was not the idea for the final solution, but I come to that later. Here you see some impressions, what was done already. I have to say, unfortunately, the second foil skipped with all the partners, but it was started under the initiative of the Chamber of Commerce and some local companies and the university, but in the meantime, it's a so-called flagship development or flagship project of the government, of the North Rhine-Westphalian government, and it's also funded with a couple of million euros. But this has only started this year, and it will go on for the next 2 years. So we are not finished. We are in the process, as you see here in some pictures, installing sensors in situations where no sensors were before. Yeah? Under bridges, looking at the river, looking at certain reservoirs in the woods, and so on. This is only a few pictures where you see how people are working and doing something. So, concerning now LoRaWAN. LoRaWAN was the decision for the wireless transmission of data, because we need low power devices. Yeah, it was clear if we install sensors somewhere in the middle of nowhere, let's put it that way, we cannot change batteries all the time. Yeah? So lifetime of battery in this application must be around 6 years. Yeah? And you have to imagine, and I'll come to that later, that we have to adapt the transmission rates due to the rainfall situation. So there are a lot of requirements which were not that easy. Yeah. We need a fairly high precision of measurement. That has to do with the fact that there are different types of sensors. There are also pressure sensors, not only distance sensors. There are different types of technologies which have to work together, because all these signals are put, show you a little bit later on, into a neural network where they create a complete understanding of a situation, what's happening. If you look at the device which comes from us in this case, so we are not delivering all the sensors in this project, but we are delivering here the level measurement sensor, and we specifically developed a version which can measure up to 7 meters, because we have specifically under the bridges where we measure the water of the river, we need these fairly high distances. Yeah? If you go down in the reservoirs, 2 meters or 3 meters are enough, but in some cases we have up to 7 meters. And that was specifically developed for this project. So that was one requirement. The other requirement is that we need a fairly high resolution and very exact measurement to cope with the other measuring devices. And because the situation is not always that easy from a surface of a water, for instance, you have waves, you have maybe foam and so on. There's a lot of filtering and statistical mathematics within the unit already to make sure that the information we are sending to the next layer of data processing is as valid as possible. Yeah? We don't want to send too much garbage information because of some funny situations at site. Yeah? That was also a requirement. So maybe a little bit different to most of the LoRaWAN devices you see also here. There is a lot of edge computing already in the unit itself. This is, for instance, a dashboard which will be available later on for the public. So there are two different sides in those projects. One side is more or less for the specialists. Yeah, it's not open to the public, but the public has the possibility later on to look at an open dashboard to see a little bit what are the water levels here and where, just for interest. Yeah. But this is more, let's say, to involve the population a little bit. The more interesting thing is, let's say, the professional side of that whole business. Here you see an example with 3 types of information. This is, of course, only a little bit. Yeah, we have hundreds of measurements. And here you have, for instance, the fill level, you have a flow measurement, and you have your rainfall quantity. And all these data are coming together. Yeah. So we are seeing many water levels. We will also put information like temperature, wind power, wind direction, and all this information come together in this system. And now the point is, or the goal of this whole development project is, because collecting data is one thing, yeah, but what are you doing with the data? Yeah? And here the University of Wuppertal develops a system, recurrent neutral learning system, where all this data are fed in. We are in a training process because this network has to be adapted to the landscape. Yeah, it's nothing which works everywhere. The learning process of these neural networks depends on the geographical situation at site, so it must be trained by supervised training. And you have these input layers where you have this time series signals from the sensors. You have geoposition, and you have the information from the weather forecast where they're saying, okay, heavy rainfall is going to come. This will also activate that the sensors are sending signals in a higher frequency. Yeah? So if we have a total stable situation, it's no rain, it's all clear, it's enough to send maybe a water level once a day. Yeah? But if you see the rainfall is going to start to become heavy, we can, by the downlink function, and the downlink function is here used in a very intelligent way, we can then change the values and can say we go up in a maximum to 5 minutes where we are sending data. Yeah? Because if the flood is building up, we need this information in a very short time. Yeah? And the outcome is that this system should be able to make a prediction. Yeah? So we know if the thing is starting here, building up some floods, the system will automatically predict what is the situation in 2, 3, 4, 5 hours in other positions of the country. So that is the research project which is running at the moment. As I said before, the project is running for 2 more years. The whole results of this project will be open. That means everybody can use this software which will be developed here by the university. Of course, it has to be trained locally, but the whole concept at the end of this research program will be open to the public. Yeah, that is what I want to tell you. And if there are questions, I will be pleased to answer. Yeah. Well, there are practically 3 layers of working with information. Yeah? One very generic layer is in the device itself, where we do some filtering, some statistics, some looking at extreme values which make no sense. when we have a second layer, I couldn't show you that because the foils are not completely ready. We have a second layer where all these sensor signals come on a server where they are prepared to be fed in the third layer, which is then the neural network. Yeah? Because the neural network depends, for instance, in a time series that the signals come always at the same time slot. Yeah? But if we are changing that, yeah, we must do some prerequisite evaluations of the signals before it's fed into a neural network. So we have actually 3 layers of data processing in this system. Yeah.
I also have a question. What is about the accuracy of the model actually? And the second question is, must it be retrained afterwards? And also, is it using the geographic circumstances around the object to
I mean, it must definitely be trained in the beginning. The question whether it must be retrained after a certain time, I'm not 100% sure, because every situation can be a little bit different. Yeah, probably you will never hit it by 100% the prediction. Yeah, probably it makes sense to do some retraining, but here we lack the experience at the moment. Yeah, so I cannot answer that question for 100%. And what was your first? What do you mean with accuracy? Yeah, there's a confidential interval, but this is not determined at the moment because we are really in the beginning of the development. Yeah. Mm-hmm. No question anymore? Okay. Yeah.